In this video, we are going to look at average speed, average velocity, and also instantaneous velocity. So let's say you are moving from A to B, from kampung A pergi ke kampung B, you pergi lalu jalan kampung kan, jalan kampung kan dia tak lurus sangat. So let's say you pergi jalan bengkok-bengkok macam ni, you sampai dekat B. Jauh jarak yang you lalu sejauh let's say 15 kilometer. Dan masa yang you ambil lebih kurang dalam 30 minit. Ataupun setengah jam lah. Setengah jam 0.5 hours. Alright. What happened here is kita nak tengok what is the average speed. Okay. Average speed by definition dia adalah sama dengan total distance ataupun actual path, total distance travel, actual path bahagi dengan time, total time. So dekat sini awak dah ambil masa selama dah bergerak sejauh 15 km dalam masa 30 minit ataupun 0.5 hours. So we can say that your average speed is 30 km per hour. Average speed adalah scalar. Dia tak ada direction. And dia punya unit biasanya kita akan represent dalam kilometer per hours, mile per hours ataupun meter per second. Dan SI unit untuk average speed adalah meter per second. Okay. Next, kita nak tengok pada average velocity. So, average velocity, kita guna simbol V. Ada bracket, triangle bracket. Okay, by definition, average velocity is equal to displacement divided by time, total time. Okay, total time taken. Or we can say that displacement tadi kita dah tengok, displacement definition dia adalah change in position vector divide by delta time, ataupun change in time. Kita tengok kan, delta tu maksud dia change, okay, change in time. So what happen next is this delta R ataupun displacement boleh diambil sebagai shortest distance. So, shortest distance between A and B can be said as straight line from A and B. Let's say this straight line, its magnitude is equal to 7.07 kilometer. Okay, that means your average velocity is equal to 7.07 kilometer. We will be using the same time, which is 0.5 hour. We said that your average velocity is equal to 14.14 kilometer per hour. And the direction for average velocity should be same as direction of your displacement, same as delta R. So delta R, you can see the previous video, it is from initial to the final position. So this is your delta R, and by definition of average velocity, this is also your what we call it, your direction for average velocity. Okay, and then next, your average velocity should be a vector. It should be a vector. That's why it has magnitude and also it has direction. The unit for average velocity, same as average speed. We have kilometer per hour, mile per hour, meter per second, or unit-unit yang boleh diambil kira. But the main unit, the SI unit, is meter per second. Okay, let's see. Let's copy this first. I want to show you this. Alright. Let's say you are travel from A to B by using motorcycle. Okay. So, boleh nampak lah dia punya speedometer kan. Dia punya speedometer. Dalam masa 5 minit, after 5 minit, you dah sampai dekat sini. Let's put it X1. Okay, dalam masa 5 minit, you dah sampai X1. Bila you tengok dekat speedometer, your V1 is equal to 10 km per hours. You jalan lagi, dalam masa another 5 minutes, jarak dia 5 minit lagi, you dah sampai second point, which is X2. And then, after 20 minutes, from beginning, maksudnya 10 minit selepas point X2, you sampai dekat point X3. Daripada A pergi X3, you dapat jarak you sejauh lebih kurang 10 km, for example. Sampai X3 dah sampai 10 km. Masa yang diambil untuk sampai X3 adalah 20 minit. Okay, what I want to say here is about instantaneous velocity. By definition, instantaneous velocity, the symbol is V, is equal to limit time approaching to 0, delta R, delta T. Up until tu, ataupun you can have V equal to differentiation of dr over dt. So here your V is your instantaneous velocity. Your R is your distance. Displacement. Or distance can have displacement. And your T is your time. This is definition for instantaneous velocity. But actually, your instantaneous velocity is velocity at that point. At that exact point that we want, or velocity at that time. The exact time that we want. So, for example, I want a velocity, instantaneous velocity at time equal to 10 minutes. So, our instantaneous velocity at equal 10 minutes is, I forgot to put it here. So, let's say at X2, you look at your speedometer, you have V2 20 km per hour. And at X3, you look at your speedometer, you are 5 km per hour. So, the velocity at time equal to 10 minutes, which is, this is the first 5 and this is the second 5. The position after 10 minutes is X2. When you look at your speedometer, it is 20 km per hour. So, we say it, your V at 10 seconds is equal to 20 km per hour. Okay, this terbalik. Sepatutnya at that point ni kat bawah. Velocity at that time. So, let's say I want velocity at time equal to 10 minutes. I look at speedometer. The speedometer reading is 20 km per hour. So, what is velocity at that point? Let's say I want velocity when I am at 10 km from the starting point. Which is, kalau tengok dekat dalam ni, saya dah tunjukkan, dia adalah X3. So, V dekat X3, 10 km. I said, instantaneous velocity at 10 km from the starting point is equal to 5 km per hour. And then, you need to remember that instantaneous velocity is a vector. The distance should be tangent to the path. Remember, the path is the actual laluan yang awak guna. So, actual path kita, kalau dalam A to B tu yang warna merah tu lah. Yang warna merah tu actual path. What is tangent to? If you have from this point, you are went to this point, and you want to find the velocity here, you want to find the tangent here, you will have something like this. This is your tangent. The angle here and angle here should be the same. And since we are considering the velocity, the direction of velocity must follow the direction of the path, the displacement. So displacement dia akan ke sana kan? Displacement ke sana. That means your velocity pun akan ke sana. Kita akan letak ekor anak panah tu dekat point yang kita nak dan menuju ke arah anak panah tersebut. Okay. So at x1, okay, x1, awak punya tangent to the path will be something like this lah. So kita nak ambil dia punya what we call, dia punya velocity je. Kita akan start kat sini and go hard there. So this is direction for V1. And untuk V2 pun sama. Kita akan follow the path. Since the path is coincide. Dia sekali dengan the path. So this is the same lah. The same as the path yang dia lalu. Untuk V2. Untuk V3, dia punya tangent to the path is something like this. This is your V3. So ini adalah awak punya direction for V3. Okay, kita dah belajar 3. Average speed, average velocity dan juga instantaneous velocity. SI unit for instantaneous velocity juga adalah meter per second. So unit yang lain boleh jadi kilometer per hours, boleh jadi mile per hours and so on. Okay, thank you.